Okay, we've seen in previous video, if you want to turn benzene into nitrobenzene here, all you need to do is react it with an electrophile, a suitable electrophile, and the electrophile is NO2+. Okay, so if you wanted to stick X onto a benzene, X could be anything, a group X, all you need to do is generate an electrophile X+. Okay, so if we want to stick an acyl group onto benzene, and we just remind ourselves what an acyl group is. An acyl group is where you have a carbonyl and then an alkyl. So it could be that's the simplest acyl group, or you could have make it longer, so on. So an acyl group is, don't forget that an alkyl group is just CH3, CH2, CH3, so that's a methyl group, ethyl group, and so on. But an acyl group is it's got the carbonyl in it. So if we want to stick an acyl group onto, so if you want to stick an acyl group onto our benzene, all we need to do is generate this electrophile. That electrophile there. Okay, so how do we do that? Well, we're going to generate that from an acyl chloride. And in order to do that, it's called a friedel-crafts reaction. That's the two scientists who invented it. We're going to use an aluminium chloride catalyst. Okay, so let's have a look at that. So generating the electrophile, actually called the acylium ion. We won't worry about its name. We want to know how to generate that electrophile. So first of all, we're going to use an aluminium chloride catalyst. Now, aluminium is covalent. It's not ionic. And so we draw a quick dot cross diagram of it. We'll realize that it has only got 6 electrons and aluminium's out of shell. So aluminium's got 3 of its own electrons. Each chlorine, of course, has got, won't draw the electrons on all the chlorines. There's covalent aluminium chloride. So that means this means it's a pretty good acceptor of lone pairs. It tends to accept lone pairs there and form a dated bond. To form a dated bond. And that's how it works here. So what happens is we react the aluminium chloride catalyst with an acyl chloride. So if you remember what an acyl chloride looks like, yes. So acyl chloride would be like that. Okay, that's ethanoyl chloride. Okay, so how's that going to react with aluminium chloride? Well, this chlorine here, one of the lone pairs on this chlorine is going to go there. It's going to go in there, and then this bond is going to break, and that pair of electrons is going to go onto the chlorine. Okay, so let's write that down as an equation, because the example, they don't want you to draw all of this that I've drawn. They want you to show it in an equation. So let's do that. So we start off with CH3 CCl plus aluminium chloride. Now this chlorine is going to go with a full shell of electrons, so it's effectively going to be a Cl- ion, and it's going to react with the aluminium chloride. So it's going to form AlCl4-. The aluminium, that's got a negative charge on it now. And what's left over is our electrophile, the acylium ion. There. Okay, so this acylium ion is then going to react with the benzene. Now it's exactly the same mechanism as with the NO2 ion, but I will draw it just for the sake of completion. Okay, so let's do it. So here's our benzene. Again, draw it nice and big so that it's clear where your arrows are coming from and so on. Here's our AlCl3. Here's our acylium ion. Right, so the pair of electrons is going to come out of the benzene ring onto the positively charged carbon there. Pair of electrons jumping out means that the delocalization system is partially broken. So remember we said we should show it broken from that carbon to that carbon. We've now got the acyl group stuck on there. And we usually show the hydrogen on that one. There's a hydrogen on every carbon, but we show it on that one. And don't forget there's a positive charge in the species, which is shared over the whole delocalized system. And the final step in the mechanism for the electrons from the hydrogen to go back in. And we've got our substituted benzene ring now. Okay, we've got that. Now, and don't forget that a hydrogen ion is going to drop off there. I said that the aluminium chloride is a catalyst, and at the moment it's been changed into AlCl4 minus. So we need to, if it's truly a catalyst, it needs to be regenerated back to AlCl3. But it's regenerated, it reacts with that H plus. You can probably think what the product is going to be. So let's just put a little subtitle here: regeneration of the catalyst. Right, so we're going to get AlCl4 minus, reacting with the H plus. That's coming from the benzene. And that's going to form AlCl3. We've got our catalyst back, and we get a molecule of HCl gas. This reaction is always done in, it can't be done in aqueous solution because the aluminium chloride will react with water. They never ask you about reaction conditions. All they want you to know is that you need to use an aluminium chloride catalyst. Okay. Right, so that is how you stick an acyl group onto a benzene ring. And that's all the example we want you to know about. But aluminium chloride can react with other things. Aluminium chloride can act as a catalyst to stick other things on benzene rings. So if we just have a little think about, let's write down, we'll put down reagent, we'll put down electrophile, generated, and then we could have the product. So we've seen this little table here. If we want to generate the acyl ion, acylium ion, to make our product there, what reagent did we use? All we've got to do is sort of stick a chlorine onto that where the positive charge is. We used an acyl chloride. So my question is, if you want to generate this, or if you want to make this product, let's say you want to make methyl benzene, what would you use then? Well, the electrophile you should use would have to be CH3 plus. So what would the reagent you would use with your aluminium chloride catalyst? You would use that, which is chloromethane. So this is pretty versatile. You can say it's saying if I wanted to stick on an ethyl group. So that would be my electrophile, and you would use chloroethene. Okay, I'll just do a couple more. Saying if we wanted to make, if I wanted to make this, right, what would I use there? I would need to generate this as an electrophile. Sorry. So there, I would need to use 2-chloropropane as the reagent. So you want the chlorine atom on number 2. That's what you'd use there. And finally, if you just wanted to stick chlorine onto a benzene ring, you want to make chlorobenzene. Well, I'd need to generate the Cl plus ion. And how would you do that? Well, you'd use Cl attached to a Cl, i.e. you'd use Cl2 chlorine. Okay, so using the aluminium chloride catalyst, you can, it's quite a versatile way of, you need to use that with AlCl3 catalyst. It's quite a versatile way of sticking whatever you like onto a benzene ring, but it's this one here. This is the only one that the exam board want you to know about, but I thought you might as well know about the others as well, because there's not that much, there's nothing new to learn there really. Final question here is, yeah, so benzene, you can't, it's always electrophilic, isn't it? It's always electrophilic reactions it undergoes. It never undergoes nucleophilic reactions.